Thank you. Hello, everyone. Hope you have a great morning, start of the day. So we'll talk about agents, but before we start, let's talk about AI in general. AI, from my perspective, is the last technology wave. It is effectively already becoming a tool that is used in chemistry and physics. The Nobel Prizes last year have been won by people who've been using AI or AI researchers. It's used in business, it's used in entertainment, it's used in daily life. And I mean, for those who are coding, more and more of the code written is done by AI itself. And so from perspective of how the world will evolve, AI will be the interface through which we're interacting with computing. Now, the challenge is whoever controls this AI, right, however you're interacting with it, will effectively control all of these areas of our life, controls everything. And so it's extremely important that we have kind of people in control that we trust, right? Now, the challenge is if you are using kind of closed source AI models and closed source model providers, the challenge is that they effectively are in control, right? They can, with a flip of a switch, turn off the whole country from accessing AI. And imagine this is a multi-digit percentage of GDP of some countries. Or they can decide, to not respond to specific questions, or they can run ads directly in the output of the model. Now, open source, always been kind of a counter force for this, and the challenge been it's extremely expensive to develop these models. It's extremely expensive to develop software here, and so there's no sustainable model, right? As soon as you open source your model, now everybody can use it, they will serve it, and somebody else will actually make money on serving it, but the company that developed it is not. And so that's extremely big challenge, right, for some advocates of open source and really kind of decentralizes control. And so the idea of a user-owned AI kind of comes from combining this 2 points, right? We want the control to be in the user's hands. We don't want this to be in the hand of a company that's trying to make money off you. And at the same time, we want it to be focused on your success. It needs to be your well-being, your economic success. So building up on the values we already have in crypto, with ownership of assets, data, power of choice, kind of this universal interface that AI provides you should be effectively on one side, firewall from everything that's happening on the internet, and on the other side, work on your behalf, right, to get things done, be that kind of global participant. Now, this needs to be an economic model, right? This cannot be just, some new company. It needs to be an economic model that aligns incentives of researchers, developers, of users, and services that are participating in this network, right? So this needs to be a new kind of incentive structure, and this is what, we're building with user-owned AI. Now, the thesis kind of from a user experience side, right? We've kind of had internet collapsed into this Google search over past, 20 years, right? Where you would usually go to Google, Google would, run some ads on your behalf as well as provide organic search results, and then you would go to that product and you would interface with it. Now, with kind of LLMs coming out, we had a new way, right, where we can just ask a question and it'll just respond to a question, right? You don't need to go to websites, you don't need to kind of click through a lot of things and figure things out yourself. And to be clear, like this transition is happening right now. Like the more and more people I talk to using Perplexity, using ChatGPT, using one of these products, and Google is kind of actually losing more and more usage. Now, the final stage of this, right, is where your AI agents are just executing actions now on your behalf on the back end, right? And you don't kind of need to go and like check up on them and do that manually. Now, to make sure that this is actually happening, in the user-owned way, right, we need to make sure that there's a confidentiality, right? The usability of these agents will come from them knowing as much as possible about you. Like ideally, they should be listening to you every minute of the day, but you don't want all of this data now streaming to some other company who will try to monetize it. It should have kind of equal access and control of this AI capabilities, right? You don't want to like, for some people, there's a limited access, for some people you can ask medical questions and for some you don't. And again, you want users to own their data, right? And like if they decide to, they can trade it off for some assets. They want to own their assets and power of choice. So just to kind of visualize this, right? Again, current paradigm, browser, lots of payments. You have advertisers, and then you're going through search engines to different websites. The new paradigm is where you have an AI assistant, right? That's sitting on your device and is effectively representing you on the internet. And instead of going to websites, instead of even using apps, your AI assistant can now go directly and interface with services, with smart contracts, with other AI agents, and get things done, right? And effectively, you still need a way to facilitate that, and that's what we're building with Neural Network. And so, part of this paradigm shift, we're going away from users effectively being the product in this aggregator internet that we've become accustomed to, where the Googles and Amazons, etc., are effectively generating value by providing information, but they also are extracting value through this. To this user-owned agents, starting to do things on your behalf, right? This is kind of in progress. And then the final state is like this internet of agents where actually there's not even need for websites and applications because, your agent can go directly talk to a pharma agent to figure out the exact medicine you need to be designed for you on the fly, for your medical information, for your specific case. So just to give you something a little bit visual, this is, your assistant just pushing some notifications saying like, hey, I booked the tickets for the Denver trip. I'm, a fan of metal concerts, so it booked a metal concert as soon as it opened up, and it rebalanced my portfolio from Aave to a near lending protocol because there's a higher APY. So it actually executes actions on your behalf, right? Knowing what you need to do or you're planning to do. And each of this is, a separate sub-agent that actually is running on the background and doing actions. So how do we actually, achieve that, right? This is like a future. We have the picture now. Well, we need a whole host of infrastructure that enables this to be done. So first of all, we need an agent hosting, right? Like we need a way to host these agents in such a way that we know they're secure and we know they're not leaking any of your data. They're confidential. We need a way for this system to have all your data, user data, shared memory, and being able to act on it. You want a way to find agents, right, that actually doing things. So, for example, you want to buy something from this factory, or you want to, your agent talk to a pharma agent. Like there needs to be a way to discover that, and then you need a way to pay and kind of transact with that, right, and have all of the related kind of payment infrastructure for this. So this is actually what we've been building. First piece is like, how do we get confidentiality? This is, and verifiability. And verifiability is really important when we kind of move into this world, because you want to know what exactly, like maybe as individual user, you will not be inspecting code, etc. But the whole system needs to be verifiable so that, security experts, etc. can kind of verify and authenticate that the whole system works, right? And so the kind of first and foremost, right, is confidentiality and verifiability. And so to do that, we've been building a decentralized confidential machine learning cloud. So this is built on top of a trusted execution environments, which is a kind of hardware elements, which are now available in Intel, ARM, AMD, as well as works with GPUs, H200s, and Blackwells in the future. And what it allows you to do is to have the full AI pipeline, so both model inference and agentic code around it, to run inside Secure Enclave in such a way that the owner of the machine, the developers, the builders of the model are not able to see what happens there. Like it's fully kind of private from the user perspective. There's an encrypted session established with a specific machine that runs your workload, and then through that you have a whole interaction happening. And obviously, there's a payment involved in this, and you have requirements of how to make sure the network is live. So all of that is done through smart contracts and a few other technologies we've built. So that's kind of piece number one. The interesting thing that trusted execution environments give you are the fact that not just this code was run on this data and nobody's seen it, but also that only this code was run on this data, right? Which actually is something you cannot get from effectively any other methodology in the current approach. Now, there is obviously, technology will continue evolving, so there's a lot of interesting innovation on fully homomorphic encryption that can be added here. But this right now is the most pragmatic approach to actually using AI inference in a fully confidential way. So then on top of this, you build an agent hosting, right? So now you can just deploy your agents and they're going to be running in this environment and any user can come and interact with them. And obviously you have models as well that they're using. On our agent hosting, any agent is effectively a program that can use one or many different model inferences, can interact with them. It can use tools. It can actually execute any arbitrary API calls, and it can have secrets and kind of variety of other things, right? So we have actually, as of today, over 500 agents already. There is things like no-code agent builder. So if you are not a developer, you can still build agents. And you can just describe what you want. It will go find the API, read the API docs, write the code, and actually deploy that agent. Now, the other thing is that we want to introduce is kind of how these agents will actually talk to each other, right? At the end, right now, kind of people have been building agents which are mostly running on their single machine, on their single server, right? They don't have this ability to communicate across so-called trust boundaries, right? So if my agent talks to a pharma agent, they effectively are in a contraposition, right? They need to negotiate with each other. They should not share more data than they need to. And then they can, maybe request some payment and request some interactions. So AITP, HTTP for AI, is Agent Interaction Transaction Protocol that effectively describes an open protocol that people can extend with kind of how multiple agents can communicate to each other, exchange different capabilities, and then exchange different structured information and structured calls to each other. So check it out. It's open for comment. We have some implementation of this on near AI hosting with different agents, but it is a open standard that we want to kind of expand and get more people to contribute. So to give you a very specific example, you have a user who wants to buy, for example, headphones in their favorite color. You have an AI assistant agent, right, their personal assistant that is augmenting this by resolving what their favorite color is based on their private memory, and then goes to a discovery agent, which has an index of all agents in the ecosystem and beyond, and which can effectively add to the chat the other agents to kind of respond back with different options and different information, right? And maybe ask more questions for clarification. So this allows you to have kind of, your assistant being the maintainer of all of the information, while these agents may be sitting on the other side, right? They kind of, think of them as when you go to a store, to the attendant who is helping you with selecting your product. They are trying to maximize their own, revenue, etc. But your AI assistant is effectively modulating that. It can help select. It can help filter. It can get those options and pretty much re-rank them based on knowing everything about you, right? So your assistant is effectively on your side, being the main driver, effectively, of these interactions. So the other important part is security, right? We talked about verifiability. That gives you a lot of kind of properties that we want, but people can still build malicious code, right, and build malicious agents. So we want a system that actually ensures that the agents themselves are not doing anything malicious, are not trying to leak your data, are not trying to extract some information from your assistant, for example, in these conversations. So one of the approaches we're taking is to have an AI agent auditor. So when you are actually building your agents and you're deploying them, when they host it in this cloud, they're actually verified and audited by the AI itself. And maybe there's going to be a process with manual checks as well. But this ensures effectively a system that's similar to App Store, right? When you're submitting your app, there's actually a review process that happens before the apps are published, so people know that apps are more trusted. And obviously there's still permissioning model and data isolation and all those things that cloud provides, but this is a really important step. Now, long term, this is not enough. Long term, any kind of AI can be tricked by another AI, right? And that's going to be just a kind of continuous battle. The way to fix this completely is to actually have a mathematical proofs. And this is something that we long-term invest is to make sure that every single line of code should be mathematically proven for a specific interaction. So to give you an example with smart contracts, if I'm planning to put money into some Uniswap pool, what I want to know is that at any later time, I can withdraw at least as much as I put in a product of the amounts of money, right? So when I put money, there should be a proof happening, mathematical proof that the code that runs Uniswap is exactly, satisfies this criteria, right? This is my LP effectively condition. The same thing applies to agents, right? If I'm gonna share some data that with my calendar information with an agent, that agent needs to prove to me that the only thing they can do is book a single slot there and not expose that information to anyone else. So you can actually have proper mathematical proofs on all of these conditions and potentially beyond with safety and kind of even alignment, but that really is kind of a longer term research that we're working on. So just to wrap it up, all of this is powered by kind of blockchain components really to enable, the scale of transactions we need here, the ability for agents to use every chain, as well as, kind of unified liquidity layer with intents to enable them to transact with any asset, and this kind of trusted execution environment cloud that enables verified compute kind of beyond what blockchains offer. So this is a new technology wave, right? This is effectively what happened with search and Google and Facebook and everything, right? This is actually Web3 that's happening for real now. If Web2 was kind of the introduction of internet and interactivity and all of the aggregators, this is a new platform shift, and this is kind of at least $1 trillion a year of opportunity that kind of for us to capture here to really build toward this. So thank you, I appreciate, and if you have questions, find me later.